Greetings one and all, this is Team Closed AI and the topic that we have selected for SIH this year is oil spill detection by using automatic identification system, that is AIS, and satellite data. This will be a software based solution under the theme Smart Automation. We went with this topic because all the other topics sound kind of generic with ready made codes already available on GitHub for the most part, whereas this sounded kind of unique and it was also environmentally very conscious. And it also helped that we happen to have a personal mentor who works in the merchant navy, and it proved to be absolutely valuable for us to have somebody who's had first hand experience in the industry. So, currently for oil spill detection, we have manual alarm systems and smart buoys that are deployed for the same. But the main problem with these systems is the latency. It takes some time for the alarm to be raised, which can prove to be quite dangerous for the ecosystem, as time is of absolute essence when it comes to oil spills. So, our proposed solution focuses on building a predictive model that will predict oil spillage by using anomaly detection on the AIS data and then confirm or identify the vessel in distress by using satellite imagery or SAR imagery to be specific. So, this will be the basic flow of our model. First, we will be collecting and keeping track of live vessel data by using AIS. So we will be looking at parameters like speed on ground, course on ground, rate of turn, coordinates, etc. to check whether the ship is about to ground or if it's on a collision course or if it's about to overturn, etc. Then, by using anomaly detection algorithms like DBSCAN and Isolation Forest, etc., we will be detecting the outliers or the vessels in distress. Then once we do that, we will be mapping the vessel's coordinates, and by using satellite imagery, we identify the vessel in question or the oil spill if it has already taken place. Once the object detection takes place and the vessel in distress or the oil spill is confirmed, a distress alarm will be raised to the respective port authorities so that they can dispatch the rescue team as soon as possible.
Our primary goal is to develop a robust system capable of detecting oil spills efficiently and accurately. This system will serve as a crucial tool for environmental protection and maritime safety. To achieve this, we've designed a comprehensive workflow that leverages various technologies and data sources. First, we continuously monitor AIS data to identify potential distress zones and track vessel movements. Given the vast amount of data involved, we've employed Apache Spark to handle computational demands efficiently. Our data is primarily stored in GeoPackage format, which we analyze using QGIS. Additionally, we also utilize Tableau to process CSV files for supplementary information. Once a distress zone is detected, we extract the coordinates of the affected area. Then, to enhance our detection capabilities, we use satellite imagery, specifically SAR, which is provided by Google Earth Engine. This data offers valuable insights in marine environment. Then, the SAR images are segmented to potential oil spill region identification from the background using PyTorch and TensorFlow in Python. Machine learning algorithms such as CNN or conventional neural networks are employed to classify the segmented regions as either oil spill or other anomalies. Then we analyze the direction of oil spill based on factors such as wind and ocean currents. Then there are three probable outcomes. First is some other anomaly. This outcome suggests that the detected event is not likely an oil spill but could be a natural phenomena. Then a probable oil spill. This indicates that the detected event is likely to be oil spill but requires further verification. Then a confirmed oil spill, which is a most serious outcome, indicating that the oil spill has definitely been identified. Once this is confirmed, immediate response measures can be initiated, such as containment and cleanup efforts. While the system is technically feasible, given the large size of AIS and satellite data, it's not without its challenges. The risk of false positive or misdetections is a constant concern, especially when dealing with data limitations. Additionally, processing vast amount of data in real time can be computationally intensive. To address these challenges, we are implementing several strategies. First is adaptive machine learning. We are employing advanced algorithms like DBSCAN, isolation learning, and CNN that continuously learn and improve their accuracy as they process more data. Then, redundancy and cross checks. To enhance our reliability, we are implementing redundant systems and cross checking mechanisms to minimize error. Then, distributed processing. Utilizing Apache Spark, we are harnessing the power of distributed computing to handle large dataset efficiently. By combining these approaches, we are confident in our ability to create a robust and effective oil spills detection system.
Continuing on the impacts and benefits, oil spills have adverse effect on marine life and livelihood. A good example provided is from a town in Maharashtra called Dahanu. A few years ago, the town witnessed an oil spill that wreaked havoc, affecting the coastline and contaminating the soil, which in turn impacted the livelihood of fishermen and marine life. Currently, a port is in developing stage in the same area called Vadhavan Bandar. It is said to become India's largest port, ranking among the top 10 ports in Asia. It is expected to handle around 298 million metric tons per year. There is a possibility of similar mishap occurring, which could affect the points mentioned above. Our project aims to prevent such incident, helping to protect public health and livelihoods. Additionally, it will minimize the cost associated with oil spill and cleanups and damages. We have broadcast points. It is in the form of a CSV file and have attributes like MMSI, which is Maritime Mobile Service Identity, which is a 9-digit unique code given to each vessel, their base date, time, latitude, longitude, SOG, COG, and etc. Each broadcast point typically represents an AIS signal transmitted by a vessel containing information like location, speed, heading, and their time. It basically tracks down the speed of the ship, its time it's taking, location, etc. Moving to track lines. Tracklines is a geo-package file. Tracklines are the path or the route taken by a vessel over a period of time. These lines are created by connecting consecutive broadcast points. This data will allow to identify patterns in vessel movements that may be associated with oil spills, such as sudden stops or unusual deviations. This visual graphics over here are track lines. Each dotted line represents the track or the route taken by a ship to reach to the destination. This data is a huge file and cannot be loaded entirely. Therefore, it has been filtered to only the area limited to Gulf of Mexico.